And hello, hello. I think we are visible now. Hello. So today, uh, well, for a while now, I've been wanting to try to make a Doom-style game. Not, I want to preface before anything else, I'm not making a Doom-style software renderer. This is going to be a Doom-style game. It is going to be a game made in Rust, and we're going to be coding it pretty much from scratch, mostly on stream. I'm not sure if everything will be on stream just yet. I will probably get some work done on my own time, but for now, the idea is it's going to be on stream. So the first thing I have here is some milestone setup for what we want to get done. Goals, I suppose you can call them. So today we're probably going to be setting up with WInit and WGPU and getting everything set up. So that's going to be fun. So I already set up the cargo bin. Probably just gonna start up by adding in the crates we need. Air. Ah. Oh, that's my problem. So, hold on, I'm gonna pull up the WInit docs on the screen real quick. Right. So we're going to be trying to keep things separated out here, starting off with good project structure. So let's just render. Just render. Fuck. Yeah, if you can't tell, I'm fresh off of work. I am not entirely all there mentally at the moment. But hopefully things get better over the course of the stream. Rs render just mod.rs. Use mod renderer. So actually, we're going to do the menu, or the, yeah, I'm thinking project structure as it stands. This main file here is going to be what carries the actual game state. So I'm going to start making the event loop here. So probably before anything else, make main return a result. Just so, like, from the very start, you can be using question mark to do things. loop equals event loop. Oh, that's fine. New. Allow when used. We mix those up. Okay. Okay, there are no issues. All right. State. Interstate. So pub struct interstate. And this is going to be the struct that contains all the rendering state. Hence the name, if you couldn't guess. So, just do RC window, because the window reference does have to be shared around for stuff like, what's it called again? GUI and WGV. Yeah. Basically, you want an easy to pass reference to window. Render state. Okay. App state is going to, application handler. For app state. Resumed to do. Then window event to do. Okay. And over in render state, we're just going to want to import render state. And then setup state. And this is just going to set up everything. This is how we're going to handle it for now. So as it stands, it's just going to be creating a window. Mute self. Self window equals. Oh, that's gonna be option RC window. Or you know what? Because we're not always going to have a window with it. Oh. No, yeah. For the render state, you want to have a window. So actually, over here, it's going to be option render state. Self.window. And we're just going to look at window creation, RC, new. Oh, and we need to reference the event loop to set up. Loop, active event loop. Event loop dot create window attributes. Result. Use air result. Result. You know what? This could probably even be the constructor function. Result render state. Window equals okay, and there's a render state. Window. Now window. Start RC result window. Okay. We're just gonna use expect for now. Unless, actually, no. Yeah, we're gonna expect it out there. What am I doing with that? I can't even read the him. Okay. What's the... There we are. Define scope window attributes. Try RC result. Oh. Oh, I move it in. Okay. Window attributes equals as where are the window attributes even in the code? Where is the... Do I have a rest for... Yeah, I can open up that in docs. Yeah, no, real cool thing. Window attributes. Where's that struct? Struct window attributes. Perfect. We have a builder. Okay. Yeah, the Rust, there's a Rust plugin for NeoVim. Has a lot of... It has a lot of really useful features, among which is if you just hover over something, it like uses Treesetter or whatever, and it just opens up your docs, which I have over on my second monitor here. Yeah, the window.default attributes dot with title text window parent window with transparent visible. What else do we want here? Window level with title full screen position resizable. With resizable, is that with resizable, with full screen, with maximize, with visible, with transparent, with blur, transparent, with decorations, theme, with resize increment, resizable, that's going to be a bool, so I guess that's true. New thing I learned about my wonderful new thing I learned about my headset is that the microphone will disconnect even if I'm just talking into it, which is something wonderful. Yeah, just like disconnected on me for no reason. That is strange. Okay, with sizable true, that now, with title, I was gonna find the client and move its parent window. Now, so like by default, it's not gonna be floating because I'm working on a tiling window manager, and I guess I can just live with that for now. I wouldn't want it to be floating at the end product anyways. Window attributes. Okay, that's the window attributes. Window attributes. There we go. And then 40 Control W. Just shrink that back. Now for sorry, just bumped into y'all there. So for resumed, here, we're going to do self dot interstate equals interstate dot. Oop, never made this public. Interstate dot setup state. Render state. Setup state. Event loop dot okay. Oh, I forgot how that even works. Private associated function. Private. That is a public function there. There we go. And yeah, so that's going to set up the render state. Now match event. Normally, you'd want to double check your window ID to make sure it's the proper window. However, this app is only ever going to be setting up one window, ideally, so I don't think we need to bother with that. New event, colon, bare minimum for now, was requested, hit loop, exit. Gotta have the dummy state, method, match for inequality check. Well, okay, Clippy. We're just gonna have you hold on for a quick second, please. Window event. Oh, not what I wanted. Not type tonight. Redraw requested. Self.render state. And we're gonna have a pub fn redraw here, which is going to take in eventually some state. State dot let some start render state state dot redraw. And we're going to take it at self, non-mutable reference to self. Do not move out of state. There we go. Now, I want to derive, debug. Yeah, sure, why not? Default. Interested doesn't have a debug. Okay. Okay, sure. Everyone gets debug. And let app state equals app state dot default, and then event loop dot set control flow. Let's pull. Yeah, we want pull. Event loop dot run app, and then app state. Mute, and we want that to be immutable then. Okay, I think that should be it. Cargo run. First cargo compile always takes forever and a half. So quick water break. And let's look at the chat. Oh, yeah, of course, there's no chat because nobody's watching right now, which makes sense. Hey, it's practice. That's all really matters. Electro engine. That is taking for, and there we are. That's a window. It's not drawing anything, of course, but you know, it does do stuff. It shows up. If I had window titles, it would show a window title. I don't have window titles with my manager. Alright, so I have actually pulled up on hand some notes about how WDPU works. Let me see if I can't bring them over to this monitor real quick. CI. Simulator output, loop benchmark, yada yada yada. Programming. I cannot, for the love of me, find out where on earth this is. Let's. Sorry about this, folks. It's WDP learning. Guess I never located it with my Z command. 020. Then Firefox, notes.pdf. Okay. And then send this to a workspace and send that workspace over here. Okay. So, what we have here are some notes I took quite a while ago and quite foul-mouthedly on how to set up WGPU for rendering. We are going to see if I can struggle through remembering what on earth I was talking about here. So, yeah. This is going to be fun. Let me just put that back up on my second monitor. And honestly, at this point, we can probably turn this off. Oh, we have to handle application resize. Hold on. FN resize at itself. What is even the resize give you? Hold on, I need to look that back up. Or no, it's on. Not there. There. There we go. What is the size of a W in it window? Nope. Size, DPI size. You want a physical size. Okay. Physical size. I32. And do vent resized, and the what on earth does window event resize give us? Window event resized. The physical size, new size. Let some state equals at state dot new rent state new size new size. Ah, that works, right? No, physical size, construct physical size. This will take a U32. That's why I didn't look right. Max structs. New size. Method defined here. Hello? There we go. Okay. Perfect. And we are just going to handle that resizing sometime in the future. The time being, oh, we don't need that right now. Let's take a look at the notes. So, step 1 of setting up. Step 1 of setting up a GPU instance is create a GPU instance. Hold on. Rust. Can I find the docs for this? I can just open the docs from that. That is perfect. So WGPU instance. You just do that with a new GPU instance descriptor. And we can probably move these off into static functions here. Fn get instance descriptor. GPU instance equals get instance descriptor. No, actually, it doesn't. It says GPU instance new, and then get instance descriptor. Yep. Like that. Okay, so instance descriptor. What goes in there? Backends. Alright, what do we want in the backends? That's going to be primary. Backends. Primary. Flags. What are the flags? Instance flags, instance flags. Debug, validation. None of these to be worried about. And backend options. Backend options. And yeah, we could probably just default out the rest of that. Okay. So that is our GPU instance. That's the most single important thing. Alright, now for the surface. Equal to GPU. How do you create a surface? Use the instance to create a surface. Is that, I assume, GUID.create surface, that's going to be it. And then target is going to be window. Nope. Window handle? Oh. Consider removing this method call. Display handle. That's a different issue. Do I have to look up damn tutorial? Oh, thread safety. Does have to be arc. Oop. There we go. We have arc. Yeah. Window. Clone. That seems to work. This is like the most pain-inducing part of the whole thing. But that seems to work. Next up, we're going to be creating an adapter. Hold on. Okay. Instance dot quest adapter. Okay. Use GPU instance dot quest adapter, and we're going to want adapter options. Yeah, that's going to be a minor recurring flaw with this headset. Who knows, I might just have to get a real microphone. Press adapter options. WTU. Request adapter options base. Would that be the proper thing to do here? And then dot Mac. Adapter options. Power preference. None. Those high performance. This is not going to be mobile. And what are we missing? First fallback adapter. False. And compatible service. Do I need the window for this? Request adapter options. I'm looking at WInit, not WGPU docs, that's why I can't find it. Request adapter options. Incompatible service. Oh. We wanted the service for that. We'll be passing in a service. A. And the service is going to have lifetime -B. And request adapter options is going to be -A, -B. And compatible service is going to be some surf. Oh, yeah, I gotta do the -A, -B. Okay. And that's going to be at git adapter options and then at surface. Oh. Okay. Okay. And I can only assume request adapter is also returning a optional there. Oh. Oh, that's the kind of thing you have to await, isn't it? Is it? Is the adapter the thing you have to await here? And this is... I forgot we had to have something for pulling async functions here. Let me see. Bolster, is that a real thing? Yeah, let's just cargo add Polster. That should be just fine. I'm just waiting on the GPU to get information. Dot block on. And is that? Yeah, now that's the thing you. Okay. So we have our adapter now, device, and Q. Let Q geez. Okay. Business structure, instance. So, creating a surface, and then requesting an adapter. Now we have the adapter. Let's request a device. Request device. Okay. That request device also is async. Block on. Okay, so let's get device adapter. Fn get device options, GPU. That device descriptor we want? Yes, that is device descriptor we want. Device descriptor. And then device descriptor. What? Device descriptor. So the label is going to be some primary device. The required features is going to be WGPU. All the features GPU, features web GPU. And this is just if we can just default this, I think. Yeah, default. Now required limits. Yep. Whoopsie. That's kind of a pain in the ass. And we are just going to do .default for now. Now memory hints. Memory hints. Default. Let's deal with memory hints. Oh. You know what? Yeah, we just do default for the rest here. Device descriptor. And device descriptor here is going to be just static. Don't need to worry about that. And then, device options. Alright, we have our device in our queue. Now we'll need to get the compatibilities. Okay. insert adapter dot service capabilities. Oh, yeah. Surface.get capabilities, and it's just actually just a reference to the adapter. Oh. There we go. So the capabilities there. Now we need to configure the surface. Okay. Surface.configure, and then pass in a reference to the device, and fn get because I know firsthand how out of hand all this shit can get. Service configuration. The GPU service configuration. Okay. Service config has a ton of stuff here. Usage. Extra usages. So, texture usages. Under attachment. Is there a default here? Texture binding. So texture usages is the ways that textures can be used in the ways they can be used when we're writing our shaders. So right now under attachment, it looks like we could just hold on to that for now. Probably do more later. Format, texture format. Yeah. Texture format. And do an sRGB. Colon sRGB. Hold on. I want RGBA 8. Yeah, no, that'll just work. That'll work. That's common. Now width and height are going to come from the screen size. Physical size U32. Width size dot width height size dot height. Okay, present mode. Presentation of the swap chain. First and first out is the only guaranteed to be supported. 5 for last. Immediate and mailbox will crash when supported. Also, auto vsync and auto no vsync will gracefully do a designated set of fallbacks if their primary swords are unsupported. We don't need anything fancy now, so we can just go present mode. 5 for relaxed. Desired maximum frame latency. Desired maximum number of frames. The presentation should keep in advance. Consequence defaults to 2. Yeah, we could probably just do 2. That's the default. Alpha mode. And it is going to be opaque auto. Just do auto for now. And then view formats. Specifies what view formats will be allowed when calling texture. Create view on the texture returned by getTurnTexture. What are the options here? There are a million fucking formats. There's no default here? Okay. View formats. Spec. GPU. Texture format. A 8 uniform, just match what we have up there. So that is our service config options for now. Service config options, and then window dot size under inner size. Okay, and that's the service configured. So you have the swap chain and all that crap, and service.configure does not return anything. Okay, so let's add all this to the accumulated render state. Why don't we? And also get a quick drink of water. Okay, so GPU instance, WGPU instance. Now, WGPU surface. Adapter. And a device. Q. Capabilities. GPU. Service capabilities. Okay. Oh. And we will need a lifetime annotation for that. And And we can pretty much guarantee it's always going to live as long as the event loop. So that could be the borrowing lifetime here. Oh. Don't need to bother with that. Okay. Understate window, GPU instance, surface, adapter, device, queue, and capabilities. Okay, so that's a bit more render state. Now we have to do a pipeline. So which means first we have to make a pipeline layout. So let me see if I can pull that up. Hold on. Oh, give me that. Pipeline layout. Oh. Pipeline layout description. And then Rust docs. Pull up those docs. Biome group layout. Then push constant ranges. Okay. And this is where shit really gets complicated. So forgive me if I make some mistakes. Pipeline layout. Yeah. Okay. So just doing the absolute basics here is going to be a label. Yeah. Pipeline layout. Whoop. So bind group layouts. We have no bind groups yet, and then push constant ranges. It is define the range of constant. Okay, that's BMT. And hold on, we're actually going to move this to a function to just get the layout. Pipeline layout descriptor. And just turn that there. Oh. Type into the borrowed value. Well, the thing is, it's static. Borrowed value there, that is. Oh. Yeah, just static. Everything here can be statically created. So, and then we get the device, create pipeline layout. Create. Create pipeline layout. Get pipeline layout. So we have the pipeline layout. And then we create a real pipeline. So hold on. Pipeline layout. Pipeline. Yeah, those are not great notes I took. Ah, jeez. This is gonna be this is gonna be like the main render pipeline. We're just getting something up and running for now. Set pipeline, render pipeline. Yeah. And then let device.create render pipeline. Pipeline layout. References to. Ah, jeez. What am I doing now? Pipeline layout. Oh. Hold on. What on earth am I talking about over here? Render pipeline. Environment shaders. Render pipeline. Oh. Oh, we don't even have the right thing here. That makes sense. We want to be returning a render pipeline descriptor. Silly me. Render pipeline descriptor. Yada yada. Now, what did I do all that for? Okay. Just ignore me. Or don't ignore me. Keep watching, but ignore anything I say. How about that? Does that sound good? That sound like a deal to you? Okay. Label some main pipeline. Oh, missing structure fields. Now we're looking at the actual pipeline descriptor. Render pipeline descriptor. So label and then optional pipeline layout. Oh wait, we should have kept that, shouldn't we? Yeah, because we want that pipeline layout. Yeah, to create the actual pipeline. Okay. So we want to get render pipeline descriptor here, and we're going to take pipeline layout. And this means it's going to have a lifetime, so taking a reference, so under pipeline descriptor, under pipeline descriptor. Sum under pipeline. Sum layout. Oop. I should properly set that up. Now, vertex state, compiled vertex stage, entry point, the input buffer's layout. Oh, we have to be loading the shaders first. That complicates things. We do have to create the shaders before we can create the render pipelines. Okay. Okay. Okay, that does change some things. Because in my mind, the way this is going to work in the long term is that the actual shaders are going to be included in a resource pack. They're not going to be hard-coded. So we should probably hold off on setting up the actual render pipeline until the very end. And now vertex state is required. So we could probably just hard code something in. Okay, hold on. Fn set up pipeline. Now, what if we want multiple pipelines? No, we can start with just one render pipeline. And we could just say reference to the shader code, salt. Okay. And we're moving that down there. Self.device.pipeline. Okay. So we're going to be compiling the shaders in this function then. So that's going to be fun. Vertex state, or actually, no, we're probably just going to be pressing the shader module. Yeah, we can compile the shader up there. Okay. Pipeline scripter, vertex state. Okay. shader, and the entry point is going to be optional string. That's the like name. Yeah. Otherwise, expect exactly. You know what? No, we place restriction on ourselves that there's only going to be one vertex function in a shader. That's not unreasonable. Compilation options. So have that be default, and then vertex buffer layout is something we're going to have to do. It entirely is a big thing later. Compilation options, and just move it to dot dot default. Or, oh, hold on. No, compilation options. Just default that out. Borrowing there, okay. And the primitive, which our primitive is going to probably just be triangles. Or hold on, there's a whole other thing here. It's going to be triangle list, strip index format, some index format, no non-index or non-strip draws. Let's you went 3D, it's fine. Front face. Front face, counterclockwise. I prefer clockwise. That's just the way my mind works. We're going to do clockwise. Some CPU face, back face calling, please. Unclipped depth. It's not clipped 0, 1, 4. Polygon mode. Fill. And then conservative. Not personally, no. Yeah, well. Okay. Depth stencil. Depth stencil state. We're going to make a depth stencil first. Yeah, we'll get to the depth stencil later. We're just trying to get the screen clearing for now. Multi-sample. Yep. Making sure, just double check some things. Okay, yeah, audio's still good. Multi-sample state. As it stands, this game is going to be pretty grungy. So we're not going to be doing much multi-sampling at all. And then fragment. We're gonna have a fragment shader here. And it's going to be pretty much the same thing. Fragment state. Module is shader. Entry point is going to be none. There's only going to be one fragment shader. Compilation options is going to be default, and targets optional target space. That's going to be a list of target space. Option color target state. Whoop. Okay, less errors. Targets. Just blank for the time being. Options. Going to be no echoes there. Okay. Multi-view. Didn't I just do that? Multi-view render pass will not be. It's just a default. And cache. We don't need cache the pipeline for the time being. Okay. What's fucked up here? Shader returns a executed on by the current function. Well, it's not going to be owning the shader. Okay. In fact, we could probably even push further the shader initialization to even before here. The shaders are probably going to be owned by the resource system. And we could save the pipeline layout actually up here, and then just create the have the render pipeline be optional. Let's bring the pipeline back down there. Pipeline layout goes there, and then base pipeline is none for now. Okay. ice pipeline, so that's going to be at mutable self. Dot sum. Create render pipeline. Pipeline self pipeline layout. Pipeline descriptor. Ooh. Oh. Hmm. Pipeline. That guy's render pipeline. It's a pipeline layout. Oh, yeah, now that creates a pipeline layout. And then create render pipeline. Get render pipeline descriptor. What we have is background. Nice. That's great render pipeline. We have a, hold on. I think we have, I think I have something set up for this, right? Something with a quick list. No, that's not correct. Go to actions. Generate documentation template. Type alias. Actions. Generate document template. Okay. That's going to be create pipeline layout descriptor. And set self.pipeline layout is going to be device create render pipeline layout returns a pipeline layout. And that's a pipeline layout descriptor is what we want there. Create render pipeline. Oh, walk on the wrong function. Create render pipeline. Pipeline layout. Shader code. Expected. Oh, and we're just going to be parting that there. Okay. So that creates our render pipeline. Now, bind groups. Okay. So, not sure when you bother with buying groups for the time being. I mean, we might. But jeepers creepers. It's gonna be a pain in the ass. You know, yeah, let's not bother with buying groups for the time being. Let's just get it clearing. And, hold on. This bit always gets me. Find groups. Okay. Simple. Okay. What am I even doing here? I'm looking at reference right now. Okay. Hold on. Ugh. Not help that. You know, yeah, no. If we have the render state, then everything is configured. Yeah. Yeah. And self.surface get texture, and this is going to be a result returning function as well. Turning OK at the end. Okay. And let view let texture dot create view texture view descriptor. Is view descriptor and minute coder. Some render encoder. Ugh. That goes the wrong way around. Okay, there we go. And then make the render pass in its own scope. Render pass descriptor. Pass 1. attachment. This is such a load of crud. You. Who doesn't love boilerplate? Solve target. I am straight up copying off the Learn WGP right now because I am tired as hell and I cannot be bothered. Solve target none. Load up. Clear. GPU color. 0, 0, 0, 1, store. Store up store, extension attachment. None. Timestamp rights. None. Which query set. None. Okay. So that's that. That should be the most of it. Main.rs. Yep, I forgot about that bit now. For app state. And loop. Jeez, I hate lifetimes. Okay, resumed. Render state, render state, event loop. Yep. Ah, jeez. Effective event loop. So let's read what the actual issues here. Lifetime might outlive long enough. That requires that one mouse to outlive A. Okay. Okay. Fucking lifetimes. Fucking lifetimes. Okay. I am very clearly not going to be figuring this out tonight. I am fully dead. So what I'm going to do fucking perfect comedic timing with the disconnecting goddamn headset. I will come back some other time when I figured out this issue. Because I am not able to figure this out. Oh, geez, who would have told you? Who would have imagined that trying to program on camera after a long ass shift would not work well? I'll see y'all some other time. Until then.